This is a functional model of the human brain at a level capable of showing exactly what PTSD is. In this brief overview, I will make statements rather than explanations. If you do not understand it or choose to disagree with them, I suggest you review the whole model explanation which is presented in the other longer movie, PTSD Doesn't Bleed. So, if you are ready, here we go. For data input, the brain has nerves which can be modeled as electrical wires that carry a signal in the voltage level. This voltage can be represented by characters. When several nerves are examined, these characters form words. In the muscles, the voltage level stored in the characters will be applied to the muscles to force them to move. The words inputted from the nerves will be known as patterns, while the words outputted to the muscles will be known as responses. To hold matches, a simple table will be used to hold the pattern-response combinations. If the table were to hold every possible pattern, the table would be huge and take a long time to search. Therefore, the table will only have those combinations that are required to survive. But what are these? These are the ones that have already been used to survive. This requires a short period of learning in the animal's life where new pattern-response combinations are added to the table. Spaces will be added to the table to allow these new entries. After a while, the number of new patterns will drop off rapidly. At this point, it is beneficial to close off the table to allow the searches to be performed faster. While a good compromise, this decision has a fundamental logic error. This decision assumes the creature will have encountered every possible threat to its existence before the table is closed off. To adapt to new predators, the system needs a method of adapting rapidly to new threats later in life. The method of adapting to these new threats is known to humans as post-traumatic stress disorder. Before this method can be explained, the other elements of the model must be described. The next major element is the anticipation table. The purpose of this table is to anticipate the next pattern to arrive to allow the pattern response table to jump quickly to its location. To do this, the table will require 7 columns. These are the reference number, which is the row number of this table with a different name to avoid confusion with the other table's row number, the next expected pattern, the row number of the pattern response table where the pattern is located, the next reference number, which is the reference number of the next pattern expected in the cycle, the confidence level, which will hold a value representing how confident the system is that the pattern will be at the row number. The confidence level will be equal to the current confidence level plus or minus a value known as the weighting. The search width, which is the number of rows above and below the row number the system should search to locate the match. The search width will be equal to the table length divided by the confidence level plus 1. And the final column holds the action that must be performed when the entry is used. The next question is, how would the system know what the next expected pattern is going to be? Actually, that is quite simple, but you have to stop using the table for a while during a period we will call sleep. When the model was awake, all of the input patterns were placed at the bottom of the table. When it goes to sleep, the patterns are counted and groups of the same count are placed together. There are many repetitious patterns in daily life, such as beating of the heart and breathing. By counting all uses of a single item and then grouping items with the same count together, the patterns will come right out. The first entry in the action column decides whether the pattern is to be processed or not, while the second one decides whether the system should wait for the next entry or process it immediately. If the item is changed to yes, go, then the system will respond with the second entry before its pattern has arrived. This allows a dog to prepare for dinner when it hears a bell. The model now illustrates Pavlov's conditioned response. With the second pattern processed before it arrives, there is no need to specify the pattern at all. It can be left empty or set to null. Long strings of these null patterns will allow complex operations to be performed. These operations will be known as instincts. If the entry is changed to no go, then the system will not send this entry. Rather, it will send the next pattern immediately. The net effect is that it will respond with the second pattern whenever the first is encountered. This will be called a conditioned thread, and it is the method the brain will use to fix the fundamental logic error that PTSD is designed to fix. By allowing a change in how the brain reacts to the new predator, the model provides a method of learning to deal with new threats later in life. To do this, all that is required is to send the memory of the encounter back through the system repeatedly, and the linkages will form. This explains why the memory of the traumatic event is so pervasive in those suffering from PTSD. The brain is conditioning response to the event. But how does the system know what settings to use in the action column? It must run tests. During the sleep period, patterns must be sent through the system to see how it responds. The body is paralyzed to prevent the muscles from responding, and then the reactions are examined. The patterns originate in the dream machine, and the system uses memory to examine the responses. The thread controllers make use of the anticipation table by loading the data from one thread into its circuitry and then waiting for the pattern to arrive. If none of the thread controllers locates a match, the data is sent to the null adder to fill in the extra data before passing it on. The null adder passes the compound patterns onto the pattern buffer, which holds the patterns until a pattern matcher is ready to process them. The final major element in the model are the emotions. Emotions are state variables that will be modeled as compressed air tanks. Without emotions, an animal would only run away from a predator while it could detect it. With emotions, detecting a predator will cause the valve on the fear tank to be opened, and the animal will run for as long as there is pressure in the tank. Since there is no valve on the exhaust side, the lowest pressure in any tank will be equal to the pressure in the low pressure reservoir. Also, the maximum pressure will be equal to that in the high pressure reservoir. As more emotions are used, the pressures in the reservoirs will change significantly. The system would misinterpret this as changes in the emotions if the values were not corrected, such that the minimum value is equal to the pressure in the low pressure reservoir, and the maximum value is equal to the pressure in the high pressure reservoir. As the pressure difference drops, the emotions will respond over a smaller range. The emotions will become hypersensitive. In the worst case, the two reservoir pressures will be equal, and the emotion will jump from nothing to the maximum value instantaneously. Stress will be defined as the maximum pressure difference divided by the current pressure difference. The stress reading will be known as the weighting value, which will enable the conditioned response to happen faster under high stress conditions. To dump stress quickly, humans use a pump with 3 power settings. The first position will be normal, while the second position will cause a person to laugh, and the third will make a person cry. Since the system requires high stress while enduring PTSD to learn faster, the pump will always be in the normal position. The individual will never laugh or cry. To trigger PTSD, 2 sets of emotions are required. One will measure all emotional responses, while the other will measure all but the emotions from instinctive responses. This ratio will be known as traumatic stress. If the ratio becomes too large, there is something wrong with the pattern response table, and a new condition thread is required to solve the problem. Over time, as the condition thread forms, the stress level will decrease. The stress can be used as a timer to control the duration of the process. For most animals, this process would be fairly benign. For animals with a highly developed conscience, this procedure might run into difficulties. To the brain, the conscience is a huge stress amplifier. It can generate so much stress that it can actually trigger the PTSD response without any trauma around. This is why PTSD can start long after the actual traumatic event. Since stress is the timer to determine how long the process runs for, it can also prevent the process from completing. And with that, PTSD has been identified, and the reason humans have such difficulty with it has also been recognized. PTSD is the method the subconscious uses to adapt to new threats later in life. Humans have problems with it because the conscience is a stress amplifier. If you are experiencing PTSD, it is important that you seek immediate attention. The next point is that different people respond to different treatments. Find the one that works for you. For those living with someone enduring PTSD, the sufferer is not experiencing the memory for their own amusement. The brain will cycle the memory through for as long as it generates stress. Adding stress to the individual going through it will only serve to lengthen the healing process.